All, this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic divide and conquer in the lecture series Design and Analysis of Algorithms. So let's get started. So divide and conquer. Divide and conquer is an algorithmic pattern. In algorithmic methods, the design is to take a dispute on huge input, break that input into minor pieces, then decide the problem on each of the small pieces and then merge the piecewise solutions into a global solution. This mechanism of solving this problem is called a divide and conquer strategy. So divide and conquer algorithm consists of a dispute using the following three steps. So first, divide the original instance of problem into two or more smaller instances. Solve smaller instances recursively, then obtain solution to the original instance by combining these solutions. So let's see. So first, the first approach in divide and conquer is to divide. So here divide the original problem into a set of smaller subproblems. The second step is to conquer. So here every subproblem has to be solved separately. The final step is combine. So put together the solutions of the subproblems to get the solution to the whole problem. This is the strategy. The divide and conquer involves three-step process. So this is the strategy in divide and conquer method. So let's see the examples. So the examples that involve divide and conquer strategy are maximum and minimum problem, binary search, sorting, merge sort and quick sort, and the tower of Hanoi. All involves this divide and conquer strategy. Now let's see the fundamentals of divide and conquer strategy. There are two fundamental things to be in divide and conquer strategy. One is the relational formula and the next one is the stopping condition. So what is relational formula? Relational formula, it is the formula that we generate from the given technique. After generation of formula, we apply divide and conquer strategy, that is, we break the problem recursively and solve the broken subproblem. The next one will be the stopping condition. So when we break the problem using divide and conquer strategy, then we need to know that for how much time we need to apply the divide and conquer. So the condition where the need to stop a recursion steps of divide and conquer strategy is called as stopping condition. Let's see the applications involved in divide and conquer approach. So these are the basic applications of divide and conquer strategy. Let's discuss them in detail. So first application is the binary search. So binary search algorithm is a searching algorithm which is also called as half interval search or logarithmic search. It works by comparing the target value with the middle element existing in a sorted array. After making the comparison, if the value differs, then the half that cannot contain the target will eventually eliminate, followed by continuing the search on the other half. We will again consider the middle element and compare it with the target value. The process keeps on repeating until the target value is met. So this is called the binary search. The next method is quick sort. It is the most efficient sorting algorithm which is known as partition exchange sort. It starts by selecting a pivotal element value from an array, followed by dividing the rest of array elements into two sub-arrays. The partition is then made by comparing each of the element with the pivot value. The next one is the merge sort. So here it is also a sorting algorithm that sorts an array by making comparisons. It starts by dividing an array into sub-array and then recursively sort each of them. After sorting is done, it merges them back. The next one is closest pair of points. It is a problem of computational geometry. This algorithm emphasizes finding out the closest pair of points in a metric space given n points such that the distance between the pair of points should be a minimal one. Next one, Bayesian algorithm. It is an algorithm for matrix multiplication which is named as Bayesian. Next one is Cooley-Tukey faster Fourier transform algorithm. Follows divide and conquer approach and imposes a complexity, the time complexity of big O of log n. Karatsuba algorithm of for fast multiplication is the next application. So here it is one of the fastest multiplication method used. It multiplies two n-digit numbers in such a way by reducing it to at most single unit digit. Let's see the advantages. So the advantages are the divide and conquer tend to successfully solve one of the biggest problems such as Tower of Hanoi, a mathematical puzzle. Here it efficiently uses cache without occupying much space because it solves simple subproblems within the cache memory instead of accessing the slower main memory. It is more proficient than the brute force technique. Since these algorithms inhibits parallelism, it does not involve any modification, and it can be handled and incorporated by parallel processing means also. The next one is the disadvantage. Since most of its algorithms are designed by incorporating recursion, so it necessitates higher memory management. It also needs an explicit stack for which overspace can be avoided. It may even crash the system if the recursion is performed rigorously greater than the stack present in the CPU. So this is all about divide and conquer.